Let's come to discuss the architectures and architecture styles or patterns for the distributed systems. There are two categories of architecture patterns. One is software architecture and one is system architecture. Architecture basically shows the interaction or organization or the structuring of different software components and modules. So, software architecture basically focus on the logical organization of the software, how different components interact with itself, with the user, and in software architecture we also analyze how the system components are structured, in which manner the components are structured. While in system architecture, we describe the placement or structuring of software components or the placement of software components on the physical machines or hardwares. So let's come to discuss about the software architecture pattern and the system architecture pattern for the distributed systems. So architecture style shows the particular way of to configure collection of components and connectors. So we have two things in this software while analyzing the architecture. One is the component, which is a module or a submodule or the part of the module with well-defined interfaces, reusable and replaceable. Remember that on concrete level, if we define the component, so simply a component is a class. So component can be a one class or can be many classes, but mostly it is one or two classes combination, but with a well-defined interface. And connector is a communication link between the modules. So this means connector basically define the coupling type. So we have different coupling type: content coupling, stem coupling, data coupling. So through which different modules interact with each other. Remember that for the good architecture will be that where the number of connectors are less as much as possible. So architecture styles suitable for distributed systems are layer architecture, which is mostly a followed architecture pattern, object based architecture, data center architecture, event based architecture, and master slave architecture, which is also followed up to some extent. So depend on the number of users, depend on the demand, depend on the goals. We prefer particular architecture over the other. We cannot declare one architecture as the best. We cannot rank these architecture styles. So based on the conditions, on the circumstances, we prefer one architecture over the another. So these are the two examples. Here you can see that data flow from this one layer to another layer and then flow in layer wise fashion and then go back. So this is the layer based approach. We will discuss in this lecture in detail that how layer based architecture style works. And this is object. So object 1 pass message, communicate with other object. So this again can communicate. So this is bidirectional relation. This is unidirectional relation. Object 1 initiate and transfer a communication message to this object. So using method call. So method call functionality is used. Object can call another object and then communication is passed. So remember that there is a difference in the way how these two architectures are structured. Also remember that each layer can comprise of many objects. For example, there can be one object here, three objects there. So inside one layer, different objects can be embedded. So remember that object method of architecture is less structured as compared to the um, layer based approach. Object-based architecture. Object-based architecture centers around an arrangement of loosely coupled objects with no specific architecture like layers. So the arrangement of objects in the object-based architectures are quite loosely coupled as compared to layers. And unlike layer architecture, object-based architecture does not have to follow any steps in sequence. We look back, so the sequence is not necessary here. The message or information flows first to this layer, then to this layer, and then to this layer. But here there is no order of sequence followed. Each component is an object. I stated that component basically is a class. Here the class means the object, and all objects can interact through an interfaces. So interface is actually the connector through which the users pass the message. Under the object-based architecture, such interactions between components can happen through direct method call. So a method is designed, and then through method call, through function call, one object pass message to the another. At its core, communication between objects happen through a method invocation. What is method invocation? Method invocation is also called the remote procedure calls or RPC. Popular RPC system include Java RMI, web services, and REST API calls. So what is RMI? RMI is the remote method invocation. Invocation is basically to inform other, call other object. So remote method invocation is an API. It is an API that is provided by the Java. Provides a mechanism to create distributed application in the Java. So RMI allows any method to invoke methods. So you can see here, this is the client on one Java virtual machine, and this is another object. This is object. So one object calls another object using the invoke method, and RMI register is installed, which is an API actually, an API that provide a mechanism to create a distributed application. So remember that Java virtual machine actually works on the virtual machine, and that is adopted and created on Java. So virtual machine basically create logical partitionings. So the machine is here is one. If we talk about the Java, if Java is installed on some server, so machine is basically one, but it creates the virtual memory, the virtual processor. So using Java virtual machine, we can create as many as resources as possible. So there is a logical partitioning. So JVM helps to create a distributed environment, and through RMIs, then one object can call another through method invocation. So another method, another architecture style is a event-based architecture. In event-based architecture, the entire communication is through events. So an event-driven architecture consists of event producers and event consumer. So events are actually the notification events. Like when we talk about the different events in the software development, like mouse events, keyboard events, mouse events, when mouse click, mouse right click, mouse left click, mouse double click, like for text fields, like buttons. We can create events for the text fields when text cursor enter the text field, cursor out of the, so different events you can form. So events are actually the actions, and action handler are there to listen the events and then respond. So there are two things. One are the event producers, where the user produce the events, and one is the event consumer, or we can say the event listener. So when event occurs, the system gets the notification. This means that anyone who receives the event will also be notified and has access to the information. So the consumer or receiver will wait for the event producer. So when the event is occur, so then consumer will be notified, and this means the consumer will access the information. Sometimes these events are data, and at the other times they are URLs. So here the events can be the data. So when it receives the notification about the data or about URL to some resources, then the consumer will be notified. As such, the receiver can process what information they receive and act then accordingly. So these are the example. This is the basic example. We have 4 systems here. So event bus. So this means this is the event bus through which all the devices are connected. So D send the event, D create the event, and then A, B, C are notified, and then D is also informed about the subscription of particular consumer. Events are delivered in near real time, so consumer can respond immediately to events as they occur. Producers are decoupled from consumer. Remember that this is the beauty of this architecture, that producers and receivers both are decoupled. What are coupled? Coupled means that are in strong relationship. So there is not a strong relationship, there is no boundness, and a producer also does not know which consumer are listening. This is also the beauty, because if consumer producer know, so this can create a sort of kind of biasness. So like and dislikes can occur then. So producer does not know about the consumer, and that is called decoupling. And consumer are also decoupled from each other, and every consumer sees all of the events. So an event driven architecture can use the publish subscribe, also called pub sub model, or event stream model. So what is publisher and subscription? So publishing is actually the message publishing. So for that, the message infrastructure keeps track of the subscription. When an event is published, when event occurs from the producers and it is published, it sends the event to each subscriber. So subscriber is actually the receiver. So whenever one want to become the consumer, so he must have to become the subscriber. Like we can see on different YouTube channels, you will not be notified about some video until you become the subscriber. So when you become the subscriber, and this method is used in the YouTube channels. So when one become the subscriber of the channel, so whenever the producer uh, produce the video, make the video and upload it, so automatically the subscriber is notified. But here producer does not know about the which subscriber watch the video. So this is the beauty. Anyone can see the any consumer or receiver can watch the video. But remember that if new subscriber comes, so he will be notified only about the new videos, new events, no, not the old ones. Yes, he can, but it depends on the constraints. So if it is allowed, so he can see the old stuff. So after an event is received, it cannot be replayed, means cannot be repeated, and new subscriber does not see the event. So new subscriber means the subscriber coming after the publishing. So if the subscriber is subscribed to some events before event occurs, so they can see, otherwise cannot. And what is event streaming? Events are written into log. Events are structurally ordered with the partitioning. Event stream, what is event stream? Event stream is basically a sequence of business events order by time. When event stream processing, you can connect to all the data sources and normalized, enrich, and filter the data. So this is mostly used architecture. So you can see this is event broker. Event broker is actually the middleware software which produce the relationship connectivity among the producer and consumer. Event broker is a middleware that mediates, that produce the communication of event message between producers and consumer using a various message exchange patterns. Event driven architecture or EDA use event brokers to provide message infrastructure. So remember that there must be a event broker which act like a bridge between the producer and event. So what is happening here? So there are three consumer and two producers. Producers one produce the event A, producer B to produce the event B, and then event broker passed the events to the respective consumer. But consumer one, as it is subscribed to event A, so this means only A will be received by the consumer 1 and B will be received by the consumer 3, while both A and B will be received by the consumer 2. Why? Because it is consumer 2 subscribed to both A and B. When to use this architecture? Uh, Remember that this architecture is used when there are multiple subsystems, when multiple subsystems must process the same events. So when there are multi subsystems like the distributed computing, so in distributed computing the system it as a one, unlike we explained it in quite detail in last video that distributed systems consist of many systems, but for user it like a one system. So when there are multiple subsystems, subsystem mean subsystem for a one system, when they must process the same event. So this means when the multiple subsystem are working for the same events, so the best technique suitable sorry, the best suitable architecture pattern is the this one, event based driven architecture pattern, real time processing with minimum time log. And also remember that the time lag in this architecture is very less, means when producer publish the event, soon the consumer is notified and he receives the stream. Complex event processing such as pattern matching or aggregation over time windows, high volume and high velocity of data such as IoT. So IoT means Internet of Things. Internet of Things include different devices with different natures, like in home appliances. We can take example of the home appliances. We can have different hybrid type of devices. Network infrastructure is here, different type of devices are here, sensor are embedded. So and high volume of data process, so the best option is to use the event based architecture. Remember that there is a no shared data server, no share repository here. So there is no shared repository here, but like we talk about here that events are written in the log. So like if we did talk about this, so this event is generated from here and this is generated from here, so it is written in the log, but mostly the centralized repository is missing here. where the data will be permanently stored. If we use the centralized repository here, this will mean that producer 1 can see producer 2 data, so which is meaningless here. So this means that IoT systems, so as IoT systems abruptly and continuously communicating, so the time lag is small and data passing is huge, so the best option is to use the event driven architecture. Benefits: producer and consumers are decoupled, loose coupling here, no point to point integration, it's easy to add new consumer to the system. So this means there is no point to point. New consumers can be added easily. Consumer can respond to events immediately as they are arrived. Highly scalable and distributed. So this means that it favor this architecture pattern favor the distributed systems. So it is scalable. More and more users can be connected. Consumer can respond to events immediately as they arrive. Subsystem have independent views of the event stream. We have another architecture style which is called the data centered architecture. The data center architecture, as the name shows, the centralized data, and the main purpose is the accessing and updation of the data which are sent. So process interact by reading and modifying data in some shared repository. Shared repository means the repository, the data repository which is shared, so it can be the active or passive. What is the concept between active and passive? Active data repository is one where uh, most of the processing and event handling, most of the processing is done by the repository, while in active repository the clients are in passive mode. While in passive data repository, the repository is just used for the data storing and retrieval, nothing else. While in a passive repository, the clients are active. So if the repository is active, the client will be passive, and if the repository is passive, the clients will be active. Traditional database, which is a passive, respond to the request from the clients. Blackboard system, which is the active repository. Blackboard pattern is an active repository where clients solve the problems collaboratively. System updates clients when the system changes. So remember that in our software architecture patterns, Blackboard architecture system or pattern is explained in quite detail. So there are the three components of the Blackboard architecture. One is the controller, one is the view, and another is the mm, data repository. So the Blackboard system is trained, and the repository is updating day by day. Eventually, when the time passes, and Blackboard, so the Blackboard is a in Blackboard, the Blackboard part or the client view side is just used to enter data and view the data by the users. So Blackboard is the best example of the active repository where all the processing is done by the centralized repository, while clients are passive in Blackboard. Another example is web-based distributed systems where communication is through web services. So web-based system is also the example of data centralized architecture where there is centralized resource source of the data, and there are multiple clients which can access to this centralized repository through the um, web browser. So mostly the web-based systems are passive repository, but it can be the active repository. But mostly when we look the different websites, they are mostly the passive. So we can have a hybrid architecture, which is the combination of data center and event-based architecture. already stated that in event-based architecture there is no shared repository. So what happening here? These are two components. There is a shared repository. So this means that the system is a hybrid architecture, which is a combination of data center and remember that if these two components interact with this shared repository, so this is only the data center architecture, which can be active or passive, because these two component does not initiate any method invocation or method call. So these objects only use the shared data. So this means this component can also can use this data, and this component can also use this data. So when data is updated by this component can see it. But in hybrid architecture, which is based on both the combination of data center and event, so event can be created by one of the component, and then another component can, if it is subscribed to this component, so uh, this one can see. But remember that there is no need of such data stream logs, as data repository exists here. So this component publish, so this is actually the sender here, published event, and event comes here, and this can without subscription. There is no need of subscription is a property typically when we follow the event driven architecture, as there is no shared memory share repository here. But as we have shared repository here, so there is no need of log subscription for this component. This one publish, and this one is already connected to this centralized repository. So subscription here is already done. So this one can see the data stream published from this component. Now it's come to discuss something about the system architecture for the distributed systems. Broadly, we have two categories of system architecture: centralized and decentralized system architecture. Centralized, as the name shows, centralized where one repository or server is in center. So typically the client server architecture is example of the centralized system architecture, where multiple clients approach to the server. So remember that although if we see the distributed systems, we say that in distributed systems there are many systems which are connected together. So on server side we can have, we must have number of servers, similarly different clients which are connected to servers increases. So but for a user it should be one system. So this means either it is a one server or a combination of many systems, so still it will be a centralized. So this means server which is the combination of many system will be in center. Vertical organization of communication and control paths. So this means in centralized architecture there is a vertical organization of communication. In vertical way, the message or communication is passed from the client to the server, and logical separation of functions into the clients. Client is basically the requesting agent, and server is basically a responder. So server is basically providing the services, so it is the responder. So there is a logical separation of function into the client. While decentralized is also called peer-to-peer where instead of vertical, there is a horizontal links between different components. So it is horizontal rather than hierarchical, and control is passed in horizontal. Communication paths are less structured as compared to centralized and symmetric functionality. So we have another type which is a hybrid, which combine both centralized and P2P. So like edge server systems, collaborative distributed systems. So decentralized is also called as a collaborative architecture, because different components are different nodes are connected peer to peer. There is a link, peer to peer links. So this means they work in a collaborative fashion. So in hybrid, there is both horizontal, uh, horizontal um, or decentralized nodes, also the vertical or centralized components. So this means in hybrid there should be a one server, and with multiple clients, and different subsystems can be connected peer to peer also. So the purpose is to work collaboratively, to work efficiently, and to increase the performance. So classification of system as a centralized or decentralized refer to communication and control organization primarily. So when we talk about the traditional client server basically is the combination of client and server. So remember that web browser is not necessary. Sometimes people confuse with these two, that client server must be approached or must be accessed through browsers, but this is wrong concept. Yes, web browser, uh, and this is not also necessary that web browser system must be a client server. So these are two different phenomena. So in client server, one is a client and one is the server. So and both can be installed on a single system. So it is also not necessary that we must have to purchase the external server. Synchronous communication, request reply protocol exists. So this means request come from the client and reply or response come from the um, server. So when we develop a software using client server based approach, so we must have to implement the protocol, request reply protocol. In lens often implemented with a connectionless protocol, which is unreliable, while in WAN communication is typically connection oriented like TCP and IP. Connectionless is also called user datagram protocol. So which is difficult in WANs. So in LANs it is easier, but it is not so reliable. So we have two levels here, client and server. Remember that this approach implement on the layers level. So we have two layers. One is a client, another is the server. So request come from the client to the server, and server provide the services which back reply to the client. So the client wait for the response in terms of the results, and as the time passes the number of client requests increases. Transmission failure can occur. Failure of any sort means no reply possibilities. Request message was lost, so the message can be lost. The request message coming from the client can be lost. Reply message may be lost. Server failed either before, during, or after performing the server. So transmission failure is a part of the server client based architecture. Availability is a problem. So server may be busy, or too much request coming from, and that is the disadvantage of server client architecture, when the number of users increases, and the huge amount of request coming from different users client side. So server may be busy, and the resource scheduling become difficult, so availability can be the problem. But in distributed system, we resolve these issues, availability issues, and the reason is that we distribute the system so to better utilized and to in order to work efficiently, more efficiently. Layer architecture for client server system. So I already stated that server client system work on the layer based approach. We have user interface level GUI through which the user interact with the system. Processing level, so which is the data processing applications, the core functionalities like you implement your program in any programming your software in any programming language. So that is actually the business processing level, which where the core functionalities are implemented and installed, and which process the user request through the interface. And then data level, which interacts with the database or file system. So data exists even if no client is accessing it, file or database system. Normally in two-layer architecture, two-layer client server architecture, uh, we in two-layer architecture we have user interface and processing level in one layer, while data level in another level. So we must have data level and the processing level. Example, our web search engine interface is provide a type in a key strings. So you type a key strings. Processing level is processed to generate DB queries. So DB queries are there. So on processing level, you take the request and then process through the DB queries, rank replies, format responses, and data level is the database of the web pages. Desktops, office suites. So the interface for the this is access various documents. Processing is word processing, database queries, spreadsheets, and data is the file systems or in databases. So these are the examples of the layer based client server approach. So in more detail, if we look to the this picture, so user interface level, so user interface is designed and installed, and then we have processing layer. So HTML page containing list, HTML generator, rank algorithm, rank list of title pages, query generator, which include the different queries for insertion and selection mostly. And this is the database, which this is the data level, this is the processing level, and this is the user interface level. So this is the typically client server approach. We have implemented this in the layer based fashion. Mapping the system architecture is basically the mapping the software architecture to system hardware or resources corresponding between logical software modules and actual computers. Multi-tier architecture, layer and tier are roughly equivalent terms, but layer typically implies software and tier is more likely to refer to hardware. So in other words, we can say that in layer the separation is not physical. Uh, so but in tier the separation is physically. So in physical it includes the hardware. So two tier and three tier are most common. Two tier client server architecture are those where server provides processing and data management. Client provides the simple graphical display. So this is the thin client example. So in thin client, the on client side we only have the interface, and on server side we have a processing unit in the data. So if we look here, so in two-tier architecture these two are combined, and this one is a one tier, and these two are combined working as another tier, but this become the thin client. So thin clients are those where we have only an interface for entering and watching the data. Easier to manage, more reliable. Client machine do not need to be so large and powerful. So in small projects it work more reliable. At the other extreme, all the application processing and some data resides at clients. So this means if we want to make these two as a one in two tier, I'm talking about a two tier architecture. So if we make it as a separate tier and these two combine it as another tier, so this means on client side we have a processing level as well as user interface level. So this makes it as a fat client. So fat client include the processing level, while thin client does not include the processing level. So it depends on the technology and development tool. uh, Pros and cons are obviously pros. The pros of Fed client is that it reduce workload at server. So this means server become thin. In Fed clients approach, server become thin. So this means there is a reduction in the workload at server and become more scalable, because scalability issue occurs when there is a um, much load on the server, much load on the server, and server also is acting as a processing business processing unit. So in FAT there is a less workload, so there is no scalability issue. And if the number of user increases, so as a client are fat, so this means if we add more users, more clients, so this means the headache or the load is on client rather than the server. And the cons is it is harder to manage by the system admin, uh, less secure, so security issue can occur. So as we have given much rights to the client, so security issue can be the problem. This is multi-tier architecture. So uh, the figures on the left side is example of thin clients. We have more processing layers here. So most of the processing layers are on the server side in thin clients. When we go here, so in fat clients we have only database installed on the fat client architecture. So in this is the in between, we have the application here, which is divided into both categories, client side and server side. So this is the diagram which shows how layers are distributed. Three-tier architecture: in more some application server may also need to be clients, leading to a three-level architecture. So distributed transaction process, web servers that interact with database servers. So web-based systems that are implemented on the tier-based approach are three-tier. So remember that web-based architecture that are implemented on layer-based fashion is a three-tier. Distribute functionality across the three layers of machine instead of two. So we have these three. This is the database server, this is the application server, and this is the user interface. So this is the typical example of the three three tier. An example of server acting as a client. So request come from the user side, and application server receive this, and application server forward it to here. You will be confused with the last diagram. So the difference is that we have two separate server. One is application server and is a database server. So this is the physical separation of these three tiers together. In this example, if we see, so this is the if we see this example, so we have two layers. One is server, another is client. So this processing level and these user interface level mostly work on the single layers. Mostly in two-tier layer we have a thick client concept. So if we have thin client concept, so this is one is merged with this, so this one can be merged with either this and this. But in 3-tier architecture, the application server is a separate. Centralized versus decentralized.